We continue Unit 11, solving square root equations, with flap 4 in our foldable. Looking at example 1, we need to isolate the radical first. Notice the radical is already on one side of the equal sign, so it is isolated. Now we square both sides. R squared equals 10r. Remember to set your equation equal to 0. We do that by bringing 10r to the other side of the equation. Now we need to factor the GCF. We notice that there's an r in both terms, so I'll pull that r out. That leaves us with r times r minus 10 equal to 0. Set each factor equal to 0 and solve for r. I'm left with r equals 0 and r equals 10. Now we have to check our equation. We check our equation for extraneous solutions by putting our answers back into the original equation. And we get 0 equals to 0. That checks. So 0 is an answer. Now let's look at r equals 10. Plugging that back into the original equation also gives us a true statement. Therefore, r equals 10 is a solution. Look at example 2. The radical is already isolated, so we square both sides, resulting in x squared equals 5x minus 6. Now we solve for the variable. We set the equation equal to 0 by moving 5x and negative 6 to the other side. This gives us 0 equals x squared minus 5x plus 6. I have a quadratic equation. Therefore, I need to figure out my two factors that multiply together to give me this equation. My target product is 6. My target sum is negative 5. And the two numbers that multiply together to give me positive 6, but combine to give me a negative 5, are negative 2 and negative 3. 0 equals x minus 2 times x minus 3. We set each factor equal to 0 and solve for x. X minus 2 equals 0. Therefore, I get x is equal to 2. And I have x minus 3 equals 0. And I get x equals 3. Now I check for extraneous solutions. Plugging 2 back into the original equation gives me a true statement. Therefore, 2 is an answer. Plugging 3 into the original equation also gives me a true statement. 3 is also a solution. Example 3. Isolate the radical. Our radical is already isolated, so we square both sides. Squaring both sides gives me x squared equals x plus 56. Solve for a variable. To do this, we bring everything to one side of the equation and set it equal to 0. I get 0 equals x squared minus x minus 56. Now I need to factor. My target product is negative 56. My target sum is negative 1. The two numbers that multiply to give me negative 56 and combine to give me negative 1 are negative 8 and 7. X minus 8 and x plus 7 are my factors, so I set those equal to 0. Now I need to solve each factor for x. I get x equals negative 7 and x equals 8. I need to check for extraneous solutions. Let's start with x equals negative 7. Plugging it into our original equation does not result in a true statement. Therefore, x equals negative 7 is not an answer. When I plug x equals 8 into the original equation, I do get a true statement. Therefore, x is equal to 8. Example 4. X equals the square root of negative 7x minus 12. The radical is already isolated, so we square both sides. Again, this gives us a quadratic equation. Negative 7x minus 12 equals x squared. Now I need to solve for the variable x. I do this by moving everything to one side and setting the equation equal to 0. Now we need to find our target product, target sum. The target product is 12. The target sum is 7. The two numbers that multiply together to give me 12, but combine to give me 7, are 4 and 3. Set each factor equal to 0 and solve for x. In the first factor, x is equal to negative 3. In the second factor, x is equal to negative 4. Now I need to check for extraneous solutions. Plugging in negative 3 into the original equation results in a false statement. 3 is not equal to negative 3. Therefore, negative 3 is not my answer. Plugging negative 4 into the original equation also results in a non-true statement. 4 is not equal to negative 4. Therefore, negative 4 is also not an answer. Therefore, I have no solution. This concludes flap 4 of the foldable. Thank you.